Hey everybody, this is Larry. This is me doing a bonus question for August 6th, 2022. I'm trying to still complete why is it only there's just frequency. I did yeah, I'm trying to do one that I haven't done before and I pick it randomly. Today's earlier problem was poor pigs and it was poor me. It took a while. I hope you did it a little bit better. But yeah, let's take a look. Hopefully it's not premium. Okay, this is a easy one, so hopefully so it's a little bit better. Let's see. N repeated elements in size 2n array. So basically, what does that mean? You're given an integer array nums, two times n plus one element is repeated n times, return the element. Okay, so basically, this is phrased in a really weird way, but it is the election algorithm, right? What was it called? Freud? Is it Freud? Freud's majority algorithm. I just want to get my name right. No, that's not right. Who's some famous Boiler Moore? Okay, yeah. So I guess the thing you're looking for is Boiler Moore majority algorithm. I forgot the name. I mean, I knew the majority algorithm part. I forgot who did it, so that's my fault. But definitely read up on this. That's probably the way to go. You could. It's almost like a pigeonhole type thing of principle on the proof, but because like these problems, people got PhD and research papers and the names on these algorithms. So I'm not going to be able to get this in a couple of minutes with all the proofs. And if you are interested in that, do that. That said, I only Googled the names. So I actually don't remember the algorithm. So that, or it's not an algorithm that comes up that often, to be honest. Maybe like once in a blue moon, or in my case, even less than that. So let's see if I'm able to kind of derive it from first principle. And the idea here is that how do I even describe or think about the idea? The idea here is that you just basically keep track of the element and then you count up. You count up if you see the same thing. If not, you count down, and if it's below, I want to say if it's below zero, you take the new element instead. And there's some like we draw up the trajectory of this, the path of this. It'll always be the element that is in the majority, and some of this is just I think I call it pigeonhole. I don't know if it's quite the idea, but it's just that otherwise, yeah. I mean, there are a couple. I mean, of course, you can also sort. Given that n is 5,000, if you sort it, it'll probably be you just need a number that's the same in this case, and that'll be good. And you can also do an n squared, but why would you, right? Yeah, and you can also maybe do I want to say do a quick select. Maybe that's another way as well. Because if you choose the or like I guess given 2 times n, it can be because if you do a quick select and you do the median, right? If you do a quick select, that's also a linear time of ish thing. Because then the element is either the middle element, or like for n where n is even, it's either n over 2. So it's one of those two elements, right? So like n over 2 or n over 2 plus 1. Maybe you do it 3 times if you want to get n over 2 minus 1. And the element will be guaranteed that it'll show up in 2 of those. But I'm not going to do it that way. I'm just going to do the Boiler Moore. I think the Boiler Moore is right, though. We'll see. And in this case, because one element is repeated n times, and that means that you don't even need the majority part. Now that I think about it, you only need an element that's repeated twice. So I think the Boiler Moore even lets you do that, I think. So yeah. Is that true? Maybe not. Maybe Boiler Moore only goes up to n over 2 plus 1. Due to pigeonhole. I think maybe if it's because actually in this case, Boiler Moore may not actually run properly, because it would just I guess it does assume maybe I could think about another way though, right? So if it's n over 2, okay, yeah. I mean, so this is something that I just derived from the majority algorithm, in that the majority algorithm won't work here, won't give you a 5. But that means that this is the only scenario where it won't give you the 5, but that also means that obviously there's one case, which is that if two adjacent numbers are the same, then you could repeat or you could return it. Otherwise, it's the number plus n over 2, right? And because of the pigeonhole principle, another version of it, it has, this has to happen. Either two numbers are next to each other are the same, or two numbers skipping one number should be the same. So I think that should be good. And once we have that foundation down, oops, it is easy to write. Though this isn't quite that, not quite this, but we derive from this. Basically, the only case where, so Baltimore, when you the observation is also that if a number is repeated twice, then that's good. That's from Baltimore, because then now you won't able to go down enough. And this is the only case where it doesn't work. And in this case, by doing the math, it has to be n or I plus 2. So yeah, so we just have to try it here. If num sub I is equal to num sub I minus 1, or I plus 1, whoops. I plus 1 is less than n, and this return num sub I. Otherwise, you do the same, but for nums over 2, num plus 2, I plus 2. Yikes. Yeah. And then here we maybe assert false or something, maybe for an exception. I'm lazy, so this is gonna have to do. Yeah, so let's give it a quick submit. I haven't done it before. Hopefully this is good and I didn't forget a case. Oh no! I guess this the only case where, I guess the other case is if there's two numbers, but it has to be more than two numbers. I guess maybe, okay, I forgot the n equals 4 case. So I tried to be a little bit too clever here, perhaps. Because there are all, also I would also say that if this was a contest, definitely sorting it, and then I don't even think I would make all these observations. I would do sort it and then do a collection start. I guess I don't even need to sort it. I would just put everything in a bucket, in a collection start counter, or like a hash table, and then just count it that way. But here I am trying to do something clever. Is this the only case where this is the? Because okay, I mean we can obviously add a thing for this, but I thought this was true, but I was wrong. But this is the only case though, because now, if you think about every two pairs of numbers, this is it. And now if you add like another 9, for example, there's just no way to, be 2 away. So this is the only scenario, and I messed up. Okay, well. But I think this should do it. Hopefully. Let's give it a quick submit. Okay, yeah. Wow, how am I slower? Not quite happy that I made this mistake. I guess that's the one edge case where my thing was wrong. Because I was kind of visualizing bigger numbers in my head. Oh well. Anyway, this is O of n time, O of 1 space. That's all I have for this one. It is easy, even though I made a easy mistake. So, but also, like I said, if I was doing it for a contest, definitely would have done it another way, just because, correctness is better than these optimizations. And yeah. Anyway, that's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later then. Take care. Bye bye.